Okay, guys, I'm Jeffrey. So we're gonna do discontinuities of rational functions, alright? And we have rational functions here, and first thing you do is to factor them, right? So you have 6 and 4, and minus 6. You put your minus sign because you want a negative 2, right? And you plus 4, and you end up with a minus 2x, alright? And for your denominator, you have your 6, you have your 4, that ends up with 24, and you put 2 plus signs, and you end up with 10 plus 10x, right? Okay, so the definition of discontinuity of rational function is that you have a factor that you can cancel out on numerator and denominator, right? You have to cancel them out. But it's removed from the rational function itself, but it represents a significant point on your graph. Alright? It represents a relatively significant point, or I should say hallowed point on your graph. Okay? So this is actually when your graph approaching x to negative 4, right? So the graph is approaching here from the right hand side to the left hand side. So this right here is represented by x equals to negative 4, and you have a discontinued dot, alright, hallowed dot right here on your graph. Alright, so that's the representation. Even though you remove them, it is still attached to a graph. It is still a representation of a graph. You still cannot use negative 4, plug it into your original rational functions, and you'll still end up with a value that is undefined. So you end up with a 0 for your denominator, so that doesn't work. So your x for your domain does not equal to negative 4. Okay? So you end up with x minus 6 over x plus 6. But what is your vertical asymptote? Your vertical asymptote is your denominator that cannot be undefined. Okay? So your x is actually negative 6, right? That is your vertical asymptote. This is the vertical negative 6 right here, and your graph approaching this way or this way, we don't know yet, but it's still a representation, right? But we know for sure this is a vertical asymptote, right? And then you have your removable discontinuity. That is, we found that by canceling out the factors, right? Canceling out the factors for our numerator and denominator. Okay, so that will be negative 4, x equals to negative 4, right? Alright, so how about x equals to 0, 6? That will make the whole value 0, right? If you plug in 6 either here or here, that will make the whole value 0. So this will be 0, which is your y, the intercepts on the y-axis, right? On the y-axis. Okay, so let's do another one. So this, you do your factor first, which is 8 and 4, right? And you put your negative sign on your 4 because you want to end up with a positive 4x here. So that will be it. Okay? Negative on your 4. And how about this one? 4 and 4 and negative on both factors here, right? So what can you do with numerator and denominator here? You can remove 1, just 1, x minus 4 on both on the numerator and denominator, right? And then you end up with what? Oh, fast forward too fast. Okay, so x, okay, hopefully, Okay, so here you end up with x plus 8 and x minus 4, but your removable discontinuity will be 4, because if you plug in x2 equals to 4, this will make the original rational function undefined, right? So it's a removed or removable discontinuity, okay? And we talked about vertical asymptote, which is what? X2 equals to 4, right? That will be your vertical asymptote, right? And how about which makes the whole graph 0? That will be negative 8, right? Negative 8 will be making your value 0, right? Okay, so that will be our discussion on discontinuities of rational functions. Okay, thanks for watching and good luck on your test.